All right, so we are describing the graph, and then we're supposed to write NA if something doesn't apply. So I would write, you could say polynomial. You could probably say curve, line of symmetry NA, opens NA, vertical asymptote NA, horizontal NA. Now increasing. So we always think about our little gal or guy walking up and going from left to right. So as the person walks up this way, this is increasing. We get to here, and as we get to here, at this point, now we are decreasing. Then once I get to this point, I'm now increasing here, and this goes on to infinity. So this is going to infinity this way, positive, and then this here is coming from negative infinity. So typically we describe the increasing. So we're increasing from x is greater than negative infinity, and then less than -1, and then from x is greater than 2 to less than positive infinity. This is where it's increasing. And so then it's decreasing between these 2 points here. So x is less than 2 and greater than -1. My x-intercepts are at -2, 1, and 3. So x equals -2, x equals 1, x equals 3. My y-intercept is at y equals 3. The domain, now the domain is this way, right? The domain. And so as you look at it, as we go this way, we have an arrow, so this is going to positive infinity. As I go this way, it's going to negative infinity. So we would say this is all real numbers. Oops, that's not very good. All real numbers. And then when we look at it this way, for the range, we're going to positive and infinity this way and negative infinity here. So again, the range is going to be all real numbers as well. So all real numbers. All right. So now endpoints, there are none, so not applicable. Maximum. Now remember, a maximum is the highest point. So we could say this is a max, but notice this keeps going up. So a lot of times they'll call this a relative max. But for us, as a maximum, we're not going to call it. There's no maximum point. NA. And then is there a minimum point? Again, we have this one, but NA. And then is it continuous or discrete? It's a solid line, so it's continuous. And then is it a function? So what that means when we say is it a function, that means for every input, so when I put in 2 here, I put in 2, so x equals 2, then I get y equals -2. So for one input, I get one output. That makes it a function, so yes.